Hey guys, so got another video. Hopefully something that is going to help some of you. So I have I come across these type of jobs quite often. I actually usually do it a little bit different way, but I kind of experimented, and I think that's actually that's going to be easier and faster for me to do it. And this is going to be using line left. Um, you need a y-axis for that. Is because what's going to happen is we're going to have that end mill go go on a Y to the top, and I'll show you because I'm going to machine one part with you, and it's going to do like a radius line, and it's going to come up. So I did like a test piece, and this is what we're doing. So it's just very small flats with the radiuses at the end, as you see. Just to kind of show you what we need. So you need a starting point. What we have is, as you see, 160 here. The flat is 380. And then we know that these radiuses are 380. That's really all the information you need. The way you're going to machine it is you're going to start like do a radius, and listen, the material is actually here, so it's gonna go up because I don't know this radius. I can calculate the full radius, right? Because all you gotta do is go whatever the bottom is plus 380, because we know that radius is 380, and we can go from a center, but because we only covering about half that radius, so I don't know what's the starting Z point of that radius, so I'm going the full one, so it's just gonna cut air before it cuts into the material. So kind of let me explain maybe here. So as you see, I kind of drew a radius a little bit. So imagine this is a whole radius. I don't know what this is, but I know what's that gonna be, because all you gotta do is we have 669, so minus 10, so we do 665. 665 divided by 2, it's 300. It's 0.3325. That's going to be from here to here. Okay, and then we were moving 85,000 per side. Well, actually the whole thing, but you divide it by 2, so we're moving 42,000 and a half. From here. So all you gotta do, since the radius is 380, add 380 from here to here, and from here to here, and that's gonna be the center of your radius. Okay, so you literally go like from the center, not the whole sphere, the center. You go in, we go in here, here, then the line ends here. And then we're doing counterclockwise again over here. Let me show you the program. Okay, so we're using line left, Z and Y. Okay, so Z and Y, that means the machine is going to be cutting on a Z, and it's going up on a Y. You can go up on a Y, or you can go down on a Y. Okay, so we're doing Z and Y, position C. So the reason instead of 0 and 180, I have 90 and 270 is because if you do 0, okay, and you go to Toolpath, the machine is it's gonna show you this position. If you do 90, 180, it flips it, and you could see the bottom and the top, right? So you do path erase, shape erase, you do part, and you'll see both of these. Then you can do the path continue, and you see the behavior of the machine. So that's why I changed this from 90, so I can see it better. Same thing as when you press this one. Let me see if it's gonna show you here. See, it shows you even on here the shape, so we know we have a correct shape. Anyway, so that's why I got the position 90 here. we're moving 40,000 from A, so that's gonna be the depth of this is gonna be A, and R is gonna be depth over here. My finishes are gonna be, I put a roughing as 8, so 4008, 4008, start and open, enter R and chamfer zeros. These are all automatically populated. I put 20,000 depth of cut. You can do way more. I was just playing with it. Width of the cut, it's 200, and I'm using 312 end mill. So let's start. So first, we have a line and 0.5 R. So that's how deep it's gonna go. Okay, so let's draw the part. All right, so this is the part, but we know these are the radiuses. So now just imagine we get rid of this because, right, this is not gonna draw. So we are starting here. This is gonna be our line. And just for your, so remember, when you do your line, which is your first one, it's your starting point, the shift R, that means the tool is gonna go half an inch minus. So the R, 0, is the center of the part. I'm going another 500 deeper, right? So it passes the part. That's why, so R, in line left, X, Y and Z, or Z and Y, it's technically how deep you're gonna go. That's your R. So -5 on R, that's like literally 1 inch deep. Since it's a 3/4 part, it's gonna go 250,000 per past the part. Starting position is 0.680. So this is 0.680 on a Z, and Y, since Y is gonna be our X, right? Because we're milling, it's gonna be 712.5. And how did I come out with this number? Because I gave this, I added, like I said, this, so half plus 380, and that's how I got my, that's how I got the center of the height of this one. So this is my line, okay? And then I see counterclockwise, we're going to 160 and 336. Okay, so that means this is the counterclockwise move, and we're going to the flat over here. So as you see, counterclockwise, we're going to that flat right here, which is at 160, and 669 minus 10 divided by 2. I've erased it a little bit because I fell a little bit under the size, and then this one I added 380, right? So it's going to be that radius. Then we have that straight line. So we're staying, we're going to 1 inch 440, same Y, and obviously it's a line, so no radius, right? So this is that line here, and then we're going to come out with a counterclockwise here. So as you see, 182. How I got the 182? Because I got 160 plus the flat of 380 is 144, and I added another 380 to my length, and this is how I got my final point Z, and of course 712.5, how we originally started. So this is my position 90, and then you add 180, so you have another flat across, and now you're at 270. So you're technically, I went unit copy, I copy number 2. Let me see, copy number 2, and all I did was change the position C. Okay, so I'm gonna run it with my glasses on, coolant off. This is gonna be my first part. I only did a testing part before. Of course, make sure first part goes slower, make sure everything clears. As you see. Let's start. Okay, so this is, you can technically put in a half an inch end mill and do it with one pass, but this is what I had on the machine, and I was doing this program kind of in a hurry. Okay, so these are two rougers. So you guys see the profile. See, so it's cutting that radius up in the air. Cutting that radius still. Now just finish the army, and it's gonna, finish the radius, and it's gonna clear up. Okay, I'm back. Rotation. Let's see. Oopsie. If you have a small flat like that, like I said, you can only do one, you technically have to do one pass. You can go just to the program, go to R, for example, which is the rougher. You can go erase, and you can erase the rougher, and all it's gonna do is just do a finishing pass. Like I said, with half an inch end mill, this is not gonna be a problem. Alright guys, thank you for watching, and I'll see you next video.